Hello everyone. In today's lesson, we're going to investigate light. More specifically, light speed, or the speed of light. To help us with that, today we're using a program called Space Engine. We've used it at school before, and here I am using it at home. Space Engine can show us millions and millions of things. Right now, in Space Engine, we're standing on the surface of Earth, our home planet. Let's go for a walk along the beach. 2.82 miles per hour is roughly walking speed. How about a run? How about a really fast run? How about the fastest speed a human has ever run? Only ever so slightly faster than this. That would be Usain Bolt. Let's hop in the car. Let's go at highway speed. Let's hop into a really fast car. A car that can drive over water, of course. Let's hop into an airplane. Since we're in an airplane, let's go above the ground a little bit. Let's hop into not just any airplane, but a jet fighter. Let's hop from our jet fighter into the fastest airplane that ever was. Let's get out of our airplane and into the International Space Station. Seems pretty fast. Let's get out of the International Space Station and into New Horizons, the fastest man-made object ever made. So here we are going at about 35,000 miles per hour. No human-made object has gone faster. Since we're going so fast, let's aim at something pretty far away and see how long it'll take to get there. How about the sun? Wow, pretty bright. I can see how far the sun is from us, the player, by looking right over here in the corner. Right now, our distance to the sun is 0.99 AU. 1 AU is the distance from Earth to the sun. And since we're slightly above Earth, we're slightly closer to the sun. Just under 1 AU. Well, we're traveling at 35,000 miles per hour. Yep. I wonder how long it'll take to get there. It barely looks like we're moving at all. And the distance to the sun isn't really changing very fast at all. It's hard to tell how fast you're moving if you can't compare yourself to something. Let's look back at Earth and see if the distance from Earth has changed at all. Wow. We've come pretty far. Now 35,000 miles per hour may seem pretty fast, and really it is. But when you're in space, it's really not that fast at all. When you're in space, the distances are so vast that even moving at 35,000 miles per hour, it'll take a long time to get to the next object. If we want to get to the sun before we're all dead of old age, we'll have to increase our speed. Let's see if we can get to the speed of light. That lowercase c refers to the speed of light. So if I am going 1.05 c, that means I'm going at just about the speed of light. Maybe ever so slightly faster. Let's go. Watch the distance up there. Is it changing? Ah, yes. It sure is. But my goodness, even going at the speed of light, it's still gonna take a while to get to the sun, isn't it? It still hardly looks like we're moving at all. Why don't we take a look back at Earth and see how far we've truly come? There it is. We've come a long way. But there's still a really long way to go. Let's increase our speed. Let's go twice the speed of light. Watch the distance. Let's go 4 times the speed of light. Let's go 16 times the speed of light. At this speed, coming from Earth, it would take us about 30 seconds to get to the sun. Half of a minute. That's because traveling at light speed, 1c, light takes 8 minutes and a few seconds to get to Earth. Here we are at the sun, so we're slowing down. We're going to land in one of those dark patches. These are called sunspots. These are places on the surface of the sun which are ever so slightly cooler than the rest of the sun. It's all relative though, because according to my data on the left side of the screen, it's still 5,778 Kelvin. We'll have to use a unit converter to figure out how much Celsius or how much Fahrenheit that is. So, the surface of the sun. It's getting toasty, so let's go back to Earth. There it is. Shining like that because Earth, being mostly covered in water, and then covered above that by clouds, reflects a lot of sunlight right back at us. Let's go. Here we are at the speed of light. And again, it would take us about 8 minutes traveling at this speed, the speed of light, to get from the sun to the Earth. That's a long time, so we're going to speed up. If we go at 8 times the speed of light, it would only take us 1 minute to get to Earth. And then if we go at 16 times the speed of light, it should take about 30 seconds. I know you can wait that long. As we approach, we can see the moon off to the right side there. Getting closer, we're going to slow down to about 1c, the speed of light, and we'll pretend we're a light beam as we arrive back at planet Earth. Look at the distance changing up here. Light is really, really fast. And yet, at the same time, space is really, really big. And so even when you're moving as fast as light, it takes a while to get there.